Hello all automation lovers, I'm trying to share my skills and the most practically use Siemens PLC programming, so please subscribe and share my videos. On today's video, I'm going to show you Siemens S7300 CPU and a Phonics contact bus coupler or distributed I/O module data sharing and the I/O address mapping with the PLC. So we'll see this one. Okay. Before starting the program, let's see some information about the I/O module. So the layout looks like this one, as you see on the PowerPoint. Here is the Siemens CPU. On the bottom, here is the distributed I/O module, Phonics distributed I/O module, and its label put on the right. Okay, 16 digital I/O module, digital I/O module, digital output module. Okay, so let's see the wiring. Here is the Profinet cable, so it's connected to the Phonics distributed I/O module on the internet port, and on the bottom the power line is put on the bottom or on the orange color. So the wiring will be, I will show you the wiring later. So the other modules will, or the I/O module will receive this information from the coupler. Okay, as you see, there is a blue cable and the orange cable. Blue and the orange. So the blue is the local bus that feed by series, and the orange is the power line, also is feed by series. One option is there on the output module. The output module always needs one extra cable. That is the power for the output devices. So as you see, here is the, on the bottom there is a orange cable also. This is the power line for the output devices. So I will show you the wiring for later, this one again. Okay, so before going to the again, let's see some information. The interesting part for the Phonics I/O module is its wiring is written, or the port assignment is written on the side. As you see, this is the I/O module, so its ports are defined here. This module has four type of ports. The first is the internet port. The second is the power port, the ULS, the voltage supply for the sensors for and the logic. And the other is the local bus, and the fourth one is the input ports. So as you see, the wiring is right in here. Okay. Also, the I/O module, the input module, has three type of ports again. The first one is the local bus. The second is the voltage supply for the logic and for the sensors. And third one is the input or input ports, those 8 ports. Okay. So also you can see on the side of the module, then you can wire that based on that. And the other thing is the output module. So the output module has almost 4 port types again. The first is the local bus, the second is the voltage supply VLS, and the third is the output ports. There are 8 ports, as you see. Sorry. And the fourth one is voltage supply for the output device, the external supply, as you see here. Okay, so the wiring is written here on the device again. So let's see each port of the device on the catalog of the device. Okay, this is the I/O distributed I/O module or the bus coupler. So here is the port assignment. The ports are assigned here by number, so this description will be later put on the next page, so we'll see that one. And its LEDs, the status LEDs are also named here, so their description will be also later. We will see later. So the port definition is written here, and the LED description is also here. And the other thing is the voltage supply wiring is put on the right side, as you see. So because this device is new, so I have to put the wiring to clarify my okay. So pins 1, 4, and 5 are connected to the 24 plus, and pin 2 and 3 are connected to the 24 minus. So the wiring for this one is here. Okay, so for the input ports, these input ports are M12. So the wiring, as you know, the M12 is the pin 1 is the plus, pin 2 is the normally closed signal, pin 3 is the minus, and pin 4 is normally open signal. So for example, I put one photo P sensor here. So it gets the plus sign from pin 1 and the minus sign from pin 3. So my signal or the return signal will be connected to pin 4. Okay. Also on the bottom there is another wiring. This one is for the contact, for like a push button contact or a breaker contact or a contactor contact. So the wiring for that one is like I will connect plus sign from pin 1 and the return signal will be connected to pin 4. Okay. For the I/O modules, each port is also assigned a number here, so the description will be later. So let's see that quickly. So the description for each port is here for the I/O modules, and the status LED for each module is also named here, so their description is here. Okay, so you can see that one. So I have to add one thing on the output module because it needs one extra voltage supply, UA, as you see on the arrow. Okay, so the wiring is put on the right side, as you see. Pin 1 and the pin 4 are connected to the plus of 24 volt, and the pin 2 and the pin 3 are connected to 24 minus. Okay, so for output devices, for the port is again M12, so the wiring is put here. For one example, I put one valve here, a valve solenoid. So the minus side is the valve gives the minus from pin 3 and the controlled signal is from pin 4. So we can shut on and shut off the pin 4 to open and close the valve. So pin 5 is a ground, or the ground of that one. Okay, this is the I think I included some important points here. So let's go to the programming now. So let's create new project. Okay, PLC to phonics I/O module. I/O module. Okay, insert 300 station. Okay, let's configure the hardware configuration first. Okay, my CPU is I/O module with integrated CPU. So I have to select that one. No need to put the rack because this device has its rack on there. Okay, let's search on the catalog. Okay, this one. So let's drag and drop on the empty space. Okay, let's change it to the IP. Let's make it 1010. Create new Profinet network. Okay, sorry. So let's add the IO module now. For the Phonex module, you have to install the JCD file, or so if you want you can download from my link. I will put the link for downloading. Okay, let's drag and drop here. Let's change some parameters. IO module, let's say 20. Let's change the IP to again 20. Okay, great. So let's add the IO modules now. My modules are digital, so I will select on the digital. My first one is input module with 16 M12, and my output will be digital output with 8 ports with M12. Okay, great. So let's edit the symbol name for each one. Okay, let's say on the first one, this one, let's edit first the IP. Sorry. Yeah, let's say it's start from it, so you can edit this one. So this one start button is connected here. Start button on my for input address are assigned for each port. As you see, my module has 4 ports, but the address is 8. So for each port it has 2 input addresses. So one is for normally open and the other is normally closed. Okay, let's edit on the input again. Let's say this one, sensor 1 and sensor 2 on the other port. I'm jumping one address because those input addresses are assigned for one port. So for the other sensor I have to jump. That's why I'm jumping here. My input module has 8, but the addresses are 16, as you see. So the address mapping is this one. So the output is for each port one address. So let's say valve 1. Okay, the other one valve 2, motor. So you can name the address like this one. I need only those ones. So I have finished the hardware, so let's save and compile. Great. So now let's create one function that executes or that controls my motor and valve. Okay, let's say this one is valve 1. So if sensor 1 is active, so valve 1 will be open. Sensor 1 is on, valve 1 will be opened. Just I'm creating simple program. My target is to get the signal of the module. So let's say if sensor 2 is active, so output valve 2 will open. Sensor 2 and valve 2 will open. Okay. Let's add one network for motor control. Okay, this like sorry. Okay, let's add this one. So start button is our starting, stop is the stop again, and motor. Okay, sorry, motor 2. And for the stop hold, we can put that one, motor 2. Okay, save and compile again. Let's add our function on our OB1 to execute. Okay, done. I've done the programming, so on part 2 I will show you the actual testing of the devices. Okay, have a nice time. Thank you.